share this one. So like if we look at question 2, you're maximizing 14x plus 10y plus 12z. Actually, I need to snip that so I can see it into our workspace. Okay, and then if I click over here to the tool, the cost vector here is 14x 10y plus 12z. And then you add your constraints. So x0 is x, x1 is y, x2 is z, or whatever you end up having here. And you can add rows and columns as needed, but this is like 1x plus 1y plus minus 1z, and then it's less than or equal to 12. So then we go to row 2, that's 1x, 2y, 1z, and it's less than or equal to 32. Let me change this number over here. And then the last one is 1x plus 1y plus 0z is less than or equal to, so I got to change the sign here to 20. And then there's the constraint that they're all positive. That's I think this xi greater than 0, that means they're all positive. And we're trying to maximize. If we were trying to minimize, we would change that. And then execute. So we have to, I guess we're going to execute here, performing calculations. And it tells you that the answer is 3, 12, 32, and 20. That's not right. 14, 10, and 12. Let me just go to the end here. All right, so 24. Okay. This one is not okay. So they suggest the solution is x0 is 20. This isn't right at all. This is not 1, 1, 14, 0, 10. Struggling here because I'm not seeing the answer that I want to see. But let me.
There's a different website that you're more familiar with.
Yeah, let me try. Let me just see if this one works. I think this might be the solution 14012, but I have no way to guarantee that. So let me just submit that answer and see if that works. I think you've got tons of submissions. So nope, that doesn't work. Okay. Yeah, let me find the one that I use, not on this screen. Nope, not that one. Maybe it's there. Okay, yeah. Okay, let's try this one. So this one I feel like is more intuitive. A number of variables in your problem, you have 3 variables, x, y, and z. Okay, and your secondary conditions, that's the number of rows of equations. 1, 2, 3 here. There's 3 rows. The one limitation of this one is that it I didn't. I guess I added in too many variables. So we have.
Oh yeah, I think you accidentally put 4.
Yeah, 1, 2, 3. Okay, is it doesn't really copy and paste well, so sometimes you have to restart. So let me pull up that so I can see it. Okay, so it's 14x plus 10y plus 12z, and we're trying to maximize that. It's subject to 1x, 1y minus 1z less than or equal to 12. 1, 2, 1, 32, and then 1, 1, 0, and then that's 20. And then you always choose primal. You're not doing anything with dual problems. And what's really nice here is it just tells you the answer is 20, 12, and 0. Although I don't know how that's possible.
Wait, where are the?
Down here, x1, x2, x3.
Got it.
Oh, no, they're not in order. 20, 0, 12. Okay, that now I can see it. 20, 0, and 12. So let's go back to this one. 20, 0, and 12. Was that anywhere? 20. No. Okay. So 20, x2 is out of order, but it's 20, 0, 12. And I think it also gives you the actual maximum value, which is minus 424. Should be positive though. Okay. So if you'd like, I can continue using this calculator for these questions.
That's fine.
Okay. So you have to restart every time you go to solver. This one has 4 variables and then 4 rows of equations. And I'm just going to snip this over into the notes so I can see it while we're working at it on the other screen. Okay, so we're trying to maximize 4x, 4y, 4z, 4w. And we're trying to maximize that subject to, and then you just got to get the variables in order. So the w is missing in the first one, so it's 1, 1, 1, 0, less than or equal to 3. And the next one is missing an x, so 0, 1, 1, 1, less than or equal to 4. The next one is missing a z, so it's 1, 1. I'm sorry, it's missing a y. So it's 1, 0, 1, 1, 5. And then the next one here is missing a z, so it's 1, 1, 0, 1, 6. So the main thing here is to get it in right, because you can't go back and edit it after you. It's a limitation of this thing. So 3, 4, 5, 6. One's there. 1, 1, 1. 3 ones. Okay. All right. So our solution is 2, 1, 0, 3. Like for some reason it gives it out of order. 2, 1, 0, 3, and then it gives you the value. It says it's negative, but you always make it positive. There's probably a reason for that, but that should do it there. Okay, so we got one more here. So this is 5 variables, and 1, 2, 3, 4 constraints there. So let's go back to solver. So we got 1, 2, 3, 4, 5 variables. I think I said 4 secondary conditions. Okay, so let me snip this and okay, so we got 3x, 6y, 3z, 6w, and 3v. And then we have a lot of zeros. I actually don't know if you don't put 0 in, what it'll do, but this one is 1, 1 there for x and y. And the next one is y and z. So it looks like it's just creating this nice waterfall, and then w and v, z and w, so 1 and 1, and then 1 and 1. So we got 3, 3, 9, and 12. I'm going to try this without putting the zeros in, and we want to maximize that. Let's see if it complains. Yeah, that's interesting. Never seen that before.
Why did that happen?
Couldn't tell you. It ran into a problem while it was doing the calculation, because it's a lot of variables here. So let me put zeros in this time. 3, 6, 3, 6, 3. So 1, 1, 0, 0, 0, less than 3, 0, 1, 1, 0, 0, and then that's 3. And then we got 0, 0, 1, 1, 0, less than 9. And then 0, 0, 0, 1, 1, less than or equal to 12. Let's try it again. Okay, so don't know why that is. Let me click on practice another. It's probably a reasonable solution, like because like the variables have to add up to whole numbers. It's gonna maybe be very similar. So 0, 2, 0, 6, 2. So 0, 2. Okay, and then 0, 6. So like what I'm seeing is that like X, I'm gonna write this down here, that y is whatever number is, y is the row 1 number, like because there's a 2 here in the solution and that's 2 there, and then w is the row 4 number, and then v is whatever is left over, and then x and z are equal to 0. So let's try your problem. So your problem, like for example, if we just follow the convention there, it would be 0, comma, and then y would be 3 because of the 3 there, comma, 0, comma, and then w would be 9 because of that, and then 9 plus 3 would be that one there. So what I don't remember is like if you have to just submit that and see if it takes it.
Probably have to.
Okay, so it like that. So I would probably ask my instructor, hey, Mr. Instructor, how do I do number 4 using this calculator? Because this one may be more complex to be able to do it. To get P, we have to multiply 3 times 0, 6 times 0, so that's 18. 3 times 0 again, that's 0. 6 times 9 is 54. So we have 18 and 54, so that's 72, plus 3 times 3. Looks like it's 81 there. Just putting those numbers back into that original equation. Okay, so a couple of word problems here. Interesting. Okay. So we need to be able to write the equation, and I'll transition back to the other workspace where we actually write out the equations so you can see what's going on here. And okay, so let me share screen, new share. Okay, so the calculus textbooks are X, Y, and Z, and the profit maximizing program. So it says in the last equation you make $10 on each calculus text. That's 10x. $4 on each history test, and $8 on each marketing text. So that's your P. That's what you're trying to maximize. It's good to write that down that way you don't forget. So it says due to budget limitations, you cannot purchase more than 650 of these textbooks each semester. So that means X plus Y plus Z has to be less than or equal to 650. Calculus textbooks occupy 2 units on the shelf. History books 1 unit, and marketing text 4 units. That's 2x plus 1y plus 4z less than or equal to 1,000. Trying to decide if there's another equation there. Doesn't look like it. Okay, so if I go back to the and I won't share this because you've seen it a couple times here, but there are 3 variables. Let me actually put that into here. That link I've been using. There's 3 variables, and then there are 2 secondary equations. So we're trying to maximize 10x, 4y, 8z. Trying to maximize that, and then subject to 1x, 1y, 1z less than or equal to 650, and then 2x plus 1y plus 4z is less than or equal to 1,000. So what I can do here is snip in the solution. That might be helpful. So you'll see here that x1 is 500, x2 and x3 are 0. So your solution is 500, comma 0, comma 0. And this means positive 5,000 is your target value, optimization value. And 5,000. Okay, submitting that. Look at that, it's all correct. Great. Okay, so number 6, I'll do the same thing here. I'll snip the question in, and then we'll figure out how to write the equation. All right. You can afford to spend no more than but you're trying to minimize cost. Trying to maximize total profit. So your P here, your profit is, where's your profit? Okay, profit 1,500, and they're X, Y, and Z again. Your 1,500 for each soybean, so 1,500X plus 1,000 Y plus 500 Z. Okay, and then we got to get our constraints. So your farm encompasses 900 acres. That means at most you have X plus Y plus Z less than or equal to 900. And we have some costs. We know that like fertilizer costs something, and we only have so much fertilizer, and we only have so much hours. So for fertilizer, it's 5 for soybeans, 2 for corn. So it's 5X plus 2Y plus 1Z for wheat, and that's less than or equal to the 5,400. So again, kind of like last time, you just have to be able to know where to map the numbers, because the only thing that's going to be different is the numbers for this. And then 5 hours of labor for soybeans, that's 5X. Wheat and corn are 2 hours, so that's 2Y plus 2Z, and you only have 5,400 hours, interestingly. Okay, so that's 3 variables and 3 equations for this one. So I'll punch that in. Restart. Okay, so 3 variables and 3 equations. Okay, so we're maximizing 1,500X plus 1,000Y, 500Z. We're maximizing that. 1X, 1Y, 1Z, that has to be less than 900. And then our fertilizer cost equation, 5, 2, and 1, that has to be less than 5,400. And then our time equation is 5X, 2Y, 2Z, and that's also less than 5,400. Okay, so the nice thing, it's amazing. I mean, it solves it so quickly, and there's so much that goes into this that if you had to do this by hand, you would never want to take another math class. It's really lengthy. It's solving a matrix with, you add in slack variables and other things that don't matter. So here's your solution down here: 900, 0, 0. And it's kind of common to get those values here, and then this is always positive. So I'm going to enter those values, and then if you scroll up here, it says, will you be using all the available labor? So labor is this one right here, this last one. Basically, it's saying, like, when you put the numbers in on the left, when you put in 5 times 900 plus 2 times 0 plus 2 times 0, is there room left? Like, in this case, it equals 4,500. And see how that's less than or equal to 5,400 by 900? So the answer is no, you're not using it all. But it's that third equation, because that's the hours, the labor equation for that. So let me get these answers in. 900, 0, 0, no, and submit that. Okay, so that is correct. All right. Do you want us to move to the next section, or do you want to do this last problem before moving to the next section?
Are there 2 more sections?
Yes. I'm sorry. Yeah. I guess I'm suggesting we might not get through.
Yeah, then we can move on.
Everything. Do you want? Okay. So let me get to where I can see the next section here. So 6.4, I think had, it only has a couple of questions in it, so we can finish this one up for sure. We can definitely finish up, 6.2 and 6.3. I don't know that we're going to get, or 6.3 and 6.4. I don't know that we can get through all of them, or 15.2.
Okay.
Does that change what you want to do today at all?
No, because I feel like I know more of like derivatives from last.
Okay. Okay. All right. So let me grab this question in from 6.4, and really it's the same thing I've just done. It's now a minimized problem instead of a maximized problem. So I'm going to go back to that calculator and do the same thing, except you change it from min to max. So there's 3 variables, and then there's 3 secondary conditions. These are the secondary conditions. The xi's don't matter. So this is 4x plus 1y plus 4z. This time we're minimizing. Subject to 1, 1, 1. Now I have to change the operator to a greater than or equal to 100.
Oh wait,
And then
I can only see your workspace.
yeah, it's no different. I'll let me snip
Oh,
it in
okay.
after I'm done. You
Okay.
can, and you'll see the intermediate steps. This format doesn't work well for all the screens I have open. 1, 1. So what 1y, sorry, it's 2x plus 1y plus 0z has to be greater than or equal to 90. And we have 1y, 1z greater than or equal to 90 as well. So I'm going to snip before I say, hey, go on this thing. I'm going to paste it here. This is what it looks like. You can see 4x, 1y, 4z, minimize that. 1, 1, 1 for x, y, z greater than or equal to 100. 2, 1, 0 for 2x plus y greater than 90. 0, 1, 1 for 0x, 1y, 1z greater than or equal to 90. You always choose primal, and then you just click on next step, and I'll show you the solution here. So the solution is it cannot be determined. Wow. Okay. Did I miss something? 4, 1, 1, minimize that. Maybe that's the problem. Let me just try this one more way. Just rerunning the calculator here. This calculator is from it's in some other language, and maybe there's a translation thing. 414, 111, 210, 011. Okay. Huh. So do I miss something? 210, 011, greater than or equal to 90. Oh, I wonder. Okay, so this calculator has a limitation for this, and I'm going to do the same thing, but I'm going to try to solve the dual now. The 210 equal to 90. Minimize, okay. Wow, this one says it can't be solved. That doesn't make any sense. they've done this. I've rerun this a few times. It's not solving it. Okay, let's try your instructor's calculator here. Maybe it'll work better for these minimized problems. You share. Okay, so let's let me try this again. So this time we're trying to minimize 4, 1, and 4, and our constraint matrix is 1, 1, 1, and that's less than or greater than or equal to 100. And then we have 2, 1, 0, and that's greater than or equal to 90. And then x is 0, 1y, 1z, greater than or equal to 90. We're trying to minimize, let's go with, I don't know why it says fraction numeric. Let me just try that. And then I guess both execute buttons work. Execute. Next step. Wonder what these next steps are. Okay, they're trying to show you the steps. You don't care about that. I don't care about that either. So it's like the answer is infinite optimal solution found. So this says the same thing. Wow. What bad timing here. So let me see see what the solution is. Show answer. $0.80. So if we just get this correct, I would ask your instructor about this problem, because it using their calculator, it shows that there's no solution found. The answer is that y is whatever number is here. So it would be 0, 100, 0, and then the y value ends up being the c here. Okay. I don't know. Maybe that was frustrating, but it's. I'm frustrated because I can't believe they give you a problem you can't solve. Okay. So let's write the equations. I'll reshare the screen for this one, and let me get to where I can do that. New share. Okay, so we've got some sort of thing again. They want you to maximize total profits. Okay, great. So to maximize total profits, you're going to your profit function is this is x, y, and z. Tomatoes give you 3,000 x plus 1,500 y plus 500 z. And your farm encompasses 140 acres, so that means you have x plus y plus z less than or equal to 140. And then you have some costs. So 5, 4, and 2 for tomatoes, lettuce, and carrots. And you have 560 on fertilizer. But it says you want to spend at least that. So we got 5x plus 4y plus 2z, but it has to be greater than or equal to 560 on fertilizer. But you can only spend up to 700 hours. So that's going to be a less than or equal to 700 hours. You got 4, 2, and 2, 4x plus 2y plus 2z. So I'm going to try that calculator again, and hopefully it works this time. The one that I've been using more frequently, and I hope that gives us the right answers here, because it's kind of frustrating that we're not getting them. Okay, so let's get back to that. Okay, there it is. So we have 3 variables and we have 3 constraints, 3 secondary conditions. We're trying to maximize 3000 x plus 1500 y plus 500 z, and we know that x plus y plus z, so 1x plus 1y plus 1z has to be less than or equal to 140 because you only have 140 acres. But then you have 5x, 4y, 2z, but that one's a little different. It has to be greater than or equal to 560 because you want to spend a lot on fertilizer. I feel like that's going to create a problem, but see what the numbers say. Then 4x plus 2y plus 2z, 700 hours. We'll go ahead and solve that. Yeah, so that created a problem again.
So weird.
That's really weird. So the problem is this right here. I'm sorry, this right here. Like you would spend unlimited for this, which is really weird. Okay. Well, it actually did give a solution. So the solution it gives is that I'd look too quickly. It's 140, 140, and then 0. So let's try that. Well, that doesn't no. Sorry, 140, 0, 0. I think. Let me see here. Yeah, 140, 0, 0. So it did give a solution. I didn't catch that. So it's 140, 0, 0. And then the profit, it's 420,000. So then will you use all 140 acres of your farm? I think it is yes, because we're using all of them for tomatoes. Let me give that a try here. And that worked. Shocking. Okay, so we can go back and do 6.3, the last question, or move to 15.2 for.
Let's move to 15.2.
Okay. All right, so the first question here, I'm going to snip in. It's partial derivatives, it's something that you can do once you have a proper explanation, because it's not any harder than what you've already done previously. So they give you some function here, x to the minus 5y squared plus xy squared plus 4xy. And then they want you to take the derivative of this function with respect to x. That's what this means right here. Take the derivative of this with respect to x. So if you just took the derivative with respect to x, you'd say it's minus 5x to the minus 6 power. Do you agree with that?
Yeah.
Just using power rule. So
Yeah.
what you do with the y and any other variable, not constants, is you treat them as a constant. So the y squared just comes along with you. What's the derivative of x?
It's not like y prime or anything.
Nope, it's just comes along with. So the derivative of x is 1. So this becomes 1y squared. Plus, what's the derivative of x? Well, it's just the number in 4 and then the y that goes with it.
Yeah.
So then you do the same thing with y in the second one here. So you go up to this first thing. What's the derivative of y squared? Well, it's 2y. This x to the minus 5th is just treated as a constant, so it comes with. What's the derivative of y squared? Well, it's 2y, and then the x comes with it. That x comes with it. You just take the derivative of y squared. It's not product rule. It's just a constant. What's the derivative of y here? Well, it's 1. So it's 1 times 4x, because that's just a constant. So it can be done, but you know,
plug in the numbers.
Yeah, here you treat y as a constant, and here you know x is constant, and then you plug in the numbers. So let's do that. So for the first one, it's minus 5, and then 1 to any power is just 1. So we'll just put 1 there, times negative 1 squared plus y is negative 1 squared plus 4 times negative 1. So this is negative 5 plus 1 minus 4. So I think that's negative 9. And then the next one here, it's 2 times negative 1. That's y is negative 1. And then 1 to any power is always 1, plus 2 times negative 1 times 1 plus 4 times 1. So this one is negative 2, and 4. So looks like that one's 0. So I'm just going to enter the answers in now. It takes the longest part. Y squared plus y squared plus 4y. All right, and then we got 2y plus 2xy plus 4x. All right, and we'll submit the answers. Okay, so I entered them incorrectly. -5 plus, oh, oops. So this one, yeah, y squared. Why did I enter that incorrectly? -5 plus 1 is -4. I think this is -8. Yep, there it is. Okay, great. All right, number 2. We're going to rewrite number 2 once I get it snipped in so you can see how to do this. I guess the first one said undefined as a possibility. Just to remind you, undefined occurs when you divide by 0. So we'll see if that happens here. So this is rewritten as 7xy plus 1 to the -4 power. So the derivative of this with respect to x, it's power rule. So you bring that -4 down. That's -28. xy plus 1 to the -5 power. Then you go inside here. So if it was just xy plus 1, the derivative of x is 1, but there's a y with it, so the y stays there. The derivative of 1 is 0. So this becomes -28y xy plus 1 to the -5 power. When you take the derivative with respect to y now, it's the same start. It's totally the same start. You bring the -4 down, so it becomes -28 xy plus 1 to the -5 power. And the derivative with respect to y is 1, but there's an x there, so you multiply by x. You get this -28x xy plus 1 to the -5th power. Now you evaluate it at 1 and -1. So you'll see that when you multiply them together down here, you get -1. And -1 plus 1 is 0. When 0 is on the bottom, to any power, it's 0. So that's undefined for both of these. Get that knocked out, or 28 y xy plus 1 to the -5 power. Whoa. And then they're both undefined. Let's see if it accepts that. Great. Let's see what it's got here. Didn't like, oh, I copied over. Okay, yeah, it's x, not y. Okay. I entered this wrong in both of these. It's really easy to do. Okay. Number 3. There are calculators for these. Like if you search for partial derivative calculator, you can find those. I know you said you're going out of town. So those are available. All right, the derivative of this with respect to x, so you just look at what's here. Okay, I got x to the -2 power. So the derivative of that is 0.2 x to the -0.8. This other stuff just comes along with it. So if you want to, you can simplify here, and you can say, okay, well, 5 times 0.2, that's 1. So this is x to the -0.8, y to the 0.6. Now, when you do the same thing with respect to y, you're just taking the derivative of that. So it's 0.6 y to the -0.4 power. Okay, that 5 comes along, and that x to the 0.2 comes along. 5 times 0.6 is 3. 3x to the 0.2 y to the -0.4 power. All right, and then you got to do this whole 1 to the -1 thing, or 1 and -1. So in the first one here, 1 to any power is always 1. And then -1 to most powers um, I'm sorry, -1 to any power is either 1 or -1, depending on whether it's odd or even. Um, I don't know how much explanation. I mean, you could throw this in your calculator and get the numbers out, I guess, too. You're allowed to use one here.
Mhm.
So it ends up being let's see. The first one is 1, and the second one is 3 when you throw those in. So let me punch these in, see if we get the right answer, and move on to a few more here. And submit those answers. They are, why are those not coming out? Maybe it's undefined. Sorry, I'm just at a loss. Like, why are these not working out? Because the other ones work out. Let me use my calculator here, which I'm not doing. Let me get the calculator. There it is. All right, x equals 1, y equals -1, and then we have x to the minus 0.8 power times y to the 0.6 power. And I wonder if this is going to tell me that it's undefined. That one's undefined. And then the other one is probably also undefined. Minus 0.4. Yep, they're both undefined. Huh. So your calculator would return an error if you tried to do that. And that's how you would know. It's also the case that if you were to get this exact same problem on the exam, that it would also be undefined. So you can have that there, undefined. All right, let's do 4. 4 is probably the last one we'll get to today. It is another partial derivative. Imagine that. Okay, so here you have to remember how to take the derivative of e. The derivative of e is itself. And then you're looking at this 0.5 xy. So the derivative with respect to x, if you're just looking at the x and nothing else, and there's other stuff that's distracting, derivative of x is just 1. So you multiply by 0.5 and y because that's what's left over. So this becomes 0.5y e to the 0.5 xy. Same thing down here, the derivative is itself with respect to y. E is always itself when you take its derivative. Then you got this thing with respect to y now. So you just look at y and you're like, oh, what's the derivative of y? Well, it's 1. That means there's a 0.5x left over, 0.5x e to the 0.5 xy. You'll see very common that that these like they look the same except for like the transposition of 2 letters. So that's kind of a common thing to see. So we got 0.5 y e to the 0.5 xy. No, I didn't do that. Okay. And then when you evaluate it, your answer is going to have e in it. So it's going to when you evaluate it down here for positive for y is -1, it's going to be negative 0.5 e to the negative 0.5. And this time it actually works out. E can take on these negative values. And then the next one is positive 0.5 because x is positive this time, but this is still negative. So I'm submitting that. And that does it there. Okay, so that is all we have time for today. Looks like, I mean, for sure in another hour we could get through all of this. So if you have another hour between now and when it's due, we can definitely get everything done for these 2 sections.
Okay, I'll let you know.
Yep. Thanks for your time, and I'll send out the notes and screen recording here shortly.
Yeah, thank you.
Okay, bye now.